Hey everyone! So we are doing our second video today, and so today the only vocab you need for 8.2, which is the section we'll be doing today, is the vertex form. So there's a couple different forms that you can write the quadratic function, and the vertex form looks like this. So f of x equals plus or minus a, and then in parentheses x minus h, oops, there should be a squared there, plus k. So I will go ahead and write in that squared later. So the important thing to know is the plus or minus is a negative, will reflect the x-axis. So if there's a negative in front of that a, your graph is going to be looking like this, going downward. And then the a is the dilation, which we talked about last video. It's going to make it shrink or stretch. This h here, the number, will move it left or right. What's important to know is that it is opposite of what you see. So like this already has a negative, so if I see minus 5, that means that it's a positive 5 value. And since there's a minus sign here, it's actually going to go to the right because it's a positive h value. And so this negative, then if this h value was a negative 5, this will become plus 5 now because two negatives will make a positive. And so then that's actually going to go to the right. Or excuse me, to the left, because it was a negative h value. And we'll do some examples because I know a lot of people need to see that visually. And then k value, it just translates it up or down. No trick, it's not opposite. It's if it's plus 2, it moves up 2. If it's minus 3, it moves down 3. So let's jump into examples so we can see some. Okay, so we just talked about the parent function, which is right here. So this is your vertex form. And so here's the squared that I was talking about earlier. That should have been on the other one that I wrote. So a negative will reflect. So if we look at some examples up here, we have the parent function, which is this one right here. Okay, so this is the parent function. We'll go ahead and just, so that was the parent function. And then where it says minus 2, that's in this spot, so it's moving it left or right. So it's inside the absolute value, so it's going to be moving it opposite. So we see a negative 2, so it's going to go to the right. Sorry, that's a horrible arrow, but it's going to be moving it to the right, so it moved 2 right. And then this one here, the plus 4, is in the spot of the k, and so it's going to be moving up 4. So from the parent function. So it's always starting here, and then it's either moving left, right, up, down, and so on. So go ahead and take a minute and pause the video and write down how you think these graphs are going to be moving. So like, for example, this one is a plus 3 on the outside of the squared. So it would be going up 3. So go ahead and take a minute and do those ones. Pause the video to do them. Okay, so hopefully you tried those. So the plus 3 we said was up 3. This is outside, again, that squared, so it's the k value, so it's going to go down 2. Outside again, so it's down 10. And then here's the difference. So here we said this is the k value, and then here is the h value. It is inside the parentheses, so it's your h. So it's going to move it left or right. And remember, it's opposite. So this is positive 1, so it's actually going left 1. Minus 5, right 5. And then this one has a bunch of them. So we have a negative in sign in front, so that's the reflect x-axis. The 3 is your a value, so dilation of 3. Minus 5 is going to move it right 5, and then positive 7 on the outside is moving it up 7. If you have any questions, please feel free to email Miss Holstad or both of us, so Miss Holstad and I. So moving on to the next example, what information do the values of h and k provide about the graph of the function? And so the graph, when you see this, actually tells you the vertex. So the vertex is h and then k. And this here is the h value. So it is opposite of what you see here. Okay, and then how does the a value affect it? We already said the a is the dilation. And if there is a negative sign, it's going to reflect the x-axis. So it's going to be going downward. Okay, so moving on, looking at example 2 now, we're going to graph the vertex. So the first step is you're going to plot the vertex. So plot the vertex, and we can see the vertex right here. And remember, it's the opposite, so our vertex here is -1, 5. And then you just go ahead, excuse me, and plot that point. So -1, 5. Okay, and then the next one is looking at, does the graph open up or down? So you have to look at this sign in the front. So does the graph go up or down? And in this case, it's going to be going down because of that negative sign. Okay, and then the next step is just evaluating 2 other points so that we can graph some more. So we're going to evaluate 2 other points. And then reflect those 2 points over the axis of symmetry. So if you remember the other day, we talked about axis of symmetry is on the vertex. So the axis of symmetry we'll do in this light little purple here is right on this line here. So we need to pick 2 points on one side of that line. So let's go ahead and plug in -2 and -4 and evaluate them. So go ahead and do -2 in here. So do PEMDAS. So we're going to do -2 plus 1 squared plus 5. So we're going to get -1 squared and times that by -2 and add 5. Well, -1 squared is 1 times -2 would be -2. So now we're at -2 plus 5, which gives us 3. And do the same thing for the other one, plugging in -4. Okay, well, plugging that in gets us -13, so that's not on our graph. So we actually need to plug in -3, and if we plug in -3, we get -3. So go ahead and plot these 2 points. So -2, 3 would be here, and then -3, -3 would be here. So then we take those 2 points and we translate them over. So this is 1 away here, so then it's 1 away there. 2 away, 2 away. And then just draw the parabola. So as best as you can, make that U shape. Okay, so go ahead and give the triads a shot. So pause the video and try those ones. Okay, so again, find the vertex. So 2, 1, and then it's going down because of that negative sign. So you plot that vertex and then pick 2 points on one side. So I picked doing 0 and 1. 0 goes to negative 11, so it is off the graph. And then same idea with the next one. Vertex is negative 1, 4, negative 4. It's going to be going up because there's no negative sign. Here's our axis of symmetry by our vertex, picking 2 points, so negative 2, negative 3. I picked on the left side each time, but you do not have to. You can do, so on this one we could have done negative 1, or excuse me, 0 and 1. It does not have to always be on the left side. And then the next thing is just making sure you translate whatever point is here going straight across on the other side of the axis of symmetry. If you have any questions, please email Miss Holstad and I. Okay, last one. We are going to do this example where these two people are playing soccer and they want to know if this goalkeeper here, standing exactly where he is going to be able to stop it. So step 1 is you're going to write the function. So f of x equals x minus 16 squared plus 11. And we got the 16 by where the vertex is and the 11 by the vertex. So we have this vertex here, right there. Then we need to find another point and plug that in order to find a. So step 2, plug in a point to find a. So we have this point right here. So we have x is 2 and y is 1.2. So we have 1.2 equals a times, in parentheses, 2 minus our 16 squared plus 11. And then go ahead and reduce all of this. So we're going to be left with minus 11 on this side would give us negative 9.8. And then a times negative 14 squared. And then negative 9.8 equals a times 196. Divide by 196 on both sides. So we get our a value is 0.5. So rewrite that. So our new equation now is f of x equals negative 0.05 times x minus 16 squared plus 11. So now you need to determine the altitude of the ball. So step 3 is determine the altitude at his position of the goal spot. So the goal spot is -3 because he is right here. Here's the 25 and he's about 22. And then so 25, because he said 3 feet away, minus 3, he's 22 feet away. So now plug 22 in for x and see if he'll be able to stop it. Okay, so plugging that in, you get 9.2. So again, we are plugging in 22 for our x. And we get 9.2. And since he can only reach 8 feet, he cannot stop it because that is above his reach. Okay, so that's it for today. I hope this made sense. And if you have any questions, please, please, please email Miss Holstad and I, and we will get back to you. Hope you all are doing well, and we miss you.